All right, so you're going to use this video to go over any of the quiz questions that you missed on your exponential quiz. I've labeled each problem with a big red number in the upper left, so you can skip through the YouTube video as you need to for ones that you need help with. So to start, tell whether each function represents exponential growth or exponential decay. Well, all three of these, if you look at them, have a variable up in the exponent, so we know that they are all exponential. Growth, remember, means that your base is greater than 1. So here our base is e, which is 2.718, so that is definitely greater than 1. Here our base is 4.25, which is bigger than 1. And here our base is 3/8, which is less than 1, so that's going to be decay. All right, so we should have growth, growth, and decay. Question 2. In 2017, Mrs. Fry's sister moved to Austin, Texas. This is a true story. During this decade, the population of Austin was approximately 494,290 people, and it was growing 3% annually. Let T represent the years since 2017, which means that when time is 0, we're talking about the year 2017. Write an equation that models this scenario. So we know our initial population is 494,290, so that would have been that guy. And then we're going to have our population growth, so we're going to have 1 plus our rate right here of 0.03, so 1.03 should go there. And then T is the years since 2017, so we would raise it to the T power. All right, question 3. The value of a mountain bike in dollars can be approximated by the model y equals 200 times 0.75 to the t, where t is the number of years since the bike was new. Identify the percentage that the bike changes each year. Remember, the percentage is kind of hidden in the base. Our equation usually would be your amount is equal to p and then 1 plus or minus r, depending, right, to the t power. So in this case, our 1 plus r has to be equal to 0.75, which means that r itself is equal to 0.75 minus 1. So r is equal to negative 0.25. I said it, I just didn't write it. So the percentage that the price changes each year would be negative 25%, or you could do negative 0.25. There's a lot of different ways you could write that answer, but it would be decreasing by 25% each year. Estimate the value to the nearest penny after 3 years. So 3 years represents a time. So we want to know, what is y equal to when t is equal to 3? So that would be jumping to your calculator. 200 times 0.75 to the third power. And we get 84.38 dollars, right? Because when it says round to the nearest penny, that would be 2 decimal places. So basically what happens is you bought your bike for $200, and after 3 years, it's only worth $84, which makes sense for how things decrease in their value. All right, match the given equation with their corresponding graphs. So all three of these are exponential growth because all of their bases are greater than 1. And if we look here, exponential growth, this one looks like exponential decay, which means that somehow we've done a reflection. All right, so we'll keep that in mind. This first one should be 3 to the x and then something lowered by 4. So our range is going to be 4 and above. So that's going to be this guy. This one, e to the negative x plus 2. So we've shifted the whole graph up 2. So our horizontal asymptote is at 2. That's this right here. And we can confirm that this negative x would be a flip over, right? So this is going to be our middle one, which by process of elimination, this should be our last one. But if we talk about it, this will take e to the x, shift it to the right 2. So there we go, to the right 2 and down 1. So that looks good. Number 5, for the graph provided, identify the following. Well, this is some sort of an exponential. We know that our exponential domain is all real numbers. Because this is exponential, there is going to be a horizontal asymptote at y equals 0. Oops, I'm one ahead of myself. There's going to be a horizontal asymptote at y equals 0, which means that our range is everything that is greater than 0. So from 0 to infinity. Number 6. This one, a lot of people got confused just because I think you assumed that they went in order, but we purposely kind of wanted you to think about it. So for the number of compounds, okay, if we see the word weekly, there are 52 weeks in a year. If we see the word monthly, there are 12 months in a year. Annually means one time per year, so that's going to happen once. Quarterly would be 4. And then daily, there are 365 days in a year. Okay, so some of you just, I think, clicked the boxes and just thought they went in order, but we really want you to think about what each one of those words means and how they correlate with a given number for your formulas. Number 7. This one kind of put together a lot of different information. We had to pull out a lot of info. So you find a house you want to buy and it costs $420,000. Luckily, you've managed to save up $20,000 for the down payment. So remember, the down payment is the cash that you have that you're ready to hand the bank right now. So that means we only need to borrow $400,000. So that's going to be how much money our loan starts as. And some people typed in the number like this, some people typed it like this, some people like this. It doesn't matter. We should have given you credit for $400,000 in some capacity. We are borrowing for 30 years. The interest will be compounding monthly. So that right away should be n is equal to 12. And our interest rate is 3.75. So r, when we're going to divide that by 100 or move the decimal over, we're going to have 0.0375, which also could be 0.0375 if that's how you wrote it. And then t, we are borrowing the money for how much time? Our time is going to be 30 years. So now that we've identified all the variables, determine how much you would have paid for the bank for your house at the end of the loan. So we're going to actually do this in our calculator. We're going to have 400 parentheses 1 plus 0.0375 divided by 12 to the 12 times 30. And let's go ahead and put that in. 400,000. Did I get all my zeros in there? Yep. Parentheses 1 plus 0.0375 divided by 12 to the, make sure if you need parentheses that you use parentheses for your 12 times 30. And we come up with 1,229,927 and 36 cents. So you really only bought a house that was worth $420,000 and you ended up paying $1.2 million because of how the bank was charging you interest, right? So this is why if you have cash on hand to buy stuff, it's better than having to take out a loan. And we're going to do more with that next week, going over those rates that we looked up before spring break. Number 8. There we go. Simplify the expression, leave exact in terms of e. Use the caret symbol for any exponents. So here we want to look at our constants. 27 divided by 3 is 9. And then e to the 7th divided by e to the 4th, because they have the same base, you're just going to subtract the exponents. So when you typed it in, it probably should have been 9e to the 3rd. This one, when we multiply with the same base, we just add across. This will be e to the 22nd, because 19 plus 3 is 22. All right, number 9, we're matching all of our different models for how we would use these for our real-world problems. So exponential growth needs to have a base that is greater than 1. So if I look at any of these, the one that's guaranteed to have a base greater than 1 is going to be this guy. Decay means that our base is between 0 and 1. So that's going to be this one. Compounding interest is where we start to have things with N and R and T. So that's going to be this guy. And then compounding continuously. Remember when you see that word continuously, we're going to use E. So that's going to be our PERT equation. Okay, so those are all really good formulas to have on a summary sheet when you are taking a quiz or a test for this class. Last one, you have an account to save up money to buy a house. It is modeled by this lovely house equation. H equals 6,224 times e to the 0.05t. How much money will you have saved after 10 years? So we are saving up for a house. We started with $6,224, and our account is going to grow for 10 years. So let's go ahead and use our calculator. 6,224. E, remember, is above the ln. 0.05. Again, make sure you use parentheses if you have the older calculator. We get 10,261.64. Right? Because we're always going to round to 2 decimals when we're talking about money. All right, so hopefully you use this video to skip around as you needed to. Make sure you complete your reflection document in Schoology as well.